Hello guys, this is our new project. This is a company that used to have a pretty big network in here with the previous tenants and now is a much smaller one. So I'm being asked to come in here and clean up this cabling. So we'll start at least with the feed. This is their ILEC feed. This is a bonded DSL modems with a lot of pairs, and those have been running over, embarrassingly, through a clip hole. This is actually supposed to be where the clip holds this cabinet in place. I'm gonna have to move that. Oh, there's their PBX system right there. And so this is the cabinet that we're going to be cleaning up. So we've got a patch panel. Most likely we've got a lot of direct lines running in and just this cascade of switches to deal with. And so it's little things that'll give me clues on this stuff. So for instance, even though these rack spaces are clearly marked, with where the spaces are, somebody mounted one kind of in between, and you'll see that the holes don't line up because of that, even though it looks like this might be completely uniform all the way through. So I know that basically whoever was working on this really wasn't familiar with rack mount equipment. So we're going to start exploring and figuring out our game plan for this today. So wish me luck, kids. Here we are shooting, or looking above the cabinet, and you can see that the cables are basically laying straight on this, in this case, pretty tore up metal. It's probably fine, but this would have been an instance where I would have preferred it to have been secured to the wall, or even this little piece of backboard just to keep it from touching the edges. Still not a big deal. The big issue now is this is my pin, so this tells me which way this cabinet is going to open. So this was my first clue to figuring that out. Okay, so I am pretty much done with what I would call just kind of a inspection or detective phase, discovery phase of the rack here in the network room. So I want to go over a couple of things that I have found here and to kind of explain what's going on. So there is, this is the feed from the outside. This is their internet connection, and it's going to give them, I believe, 5 IP addresses. And so this red line runs down to their what's going to be their phone system, a new VoIP phone. And this black line that I've now run goes to a little Netgear switch, just a dumb switch. And what that does is it splits to 2 separate consumer grade routers. So there's one, and then below here, through this big mess, is the other. So each of these routers is grabbing its own static IP off of the feed from the internet, just pairing through that switch. I'm going to try to eliminate that device and see if I can get the provider to open up one of the other ports. I already tested them, and the 2 other available ports aren't there. The whole idea here is to eliminate single points of failure. So some of the other things I've discovered. So up here is their security camera system. So a separate technician is the one that installed this router and this upper portion. So there's a switch here, another switch, some PoE injectors. And so here's a new one for me. I haven't actually seen this before, but it started when, I think, let's see if I can find it now. Yeah, here it is. I found this cable. And so this is interesting. So hopefully it'll focus on this. There we go. So what I've got here is a cable that looks like the brown and blue pairs were cut off and done some sort of pigtail like that, and then the other 2 pairs, the green and orange, were passed on through to the RJ45 connector. So I was trying to figure out what in the world is this, and then I found another, and it happened when I was tracing back all of the power cables and where they went. So I found this little brick over here, and I traced the line back, and lo and behold, I found another. So what is this? And you can see the same deal. So there's 2 pairs in here that are passed on through. Let's see if it'll focus on that. There we go. And runs up to this switch. And what this is a handmade MacGyver-style PoE injector. Same as what that other cable was, this guy right here. So what is normally done, like on this switch, there's a PoE injector. This is a whole rack of PoE injectors. They simply wanted to make one of these non-PoE ports have PoE on it without buying a PoE adapter. It must have been that this particular power supply the guy just happened to have around and it got it to work. So we're not touching any of this stuff. In fact, we've already been told by the security camera guy, just please leave my equipment alone. That's going to be unavoidable to some degree because I can't have this cascade of cables interfering. This all should have been run off to the side because this panel has to, open and close, and it needs to stay on the hinge side. So some of this is gonna have to be moved. But I can see, he basically ran out of ports here. In fact, even on the router, there's these two guys, because if you're not familiar with this, this is how you turn a standard Cat5e cable and port into two lines. So if you don't know, fast Ethernet, or that's a 100 megabit Ethernet connection, only needs 2 pairs, and it only uses 2 pairs. And any modern switch will sense what the speed is and work with it. So even though we've run 4 pairs in a cable, we always, let me get this cable out of the way, we always, for fast Ethernet, only need 2 pairs. This is where you'll wind up with voice over IP that actually uses one of these lines for the phones, and then the 4th pair is the power line or PoE. All of that changes with gigabit, so this is kind of old school, but this is how you squeeze a bit more ports out of a single cable run in a building, and you'll see a lot of this. So that's what this guy did. He ran out of lines here, so one of these, this is the WAN feed. This goes to this switch upstairs, or at the top of the rack, and then he ran 2 of these to some devices somewhere in the building. If you run around to the other side, he did that again here, which, it works. It's not very clean looking, but it works. Looks like he handmade jumper cables. I don't do that anymore. It's just too time consuming, and you don't really save any money when you buy short jumpers in bulk. They're pretty darn cheap. But basically this whole upper area is just for the security cameras, and it's a completely separate network, separate system from day-to-day operations. And what I'm going to do with this is I'm actually going to move the router up to this shelf. I'm going to put power up here and keep it completely separate. But look at how this rack kind of came together. I'm going to move this so I can back up. So there is a patch panel, 24 ports of which are here, and this just waterfall of jumper cables down to a 24 port switch down there. So yeah, you could have, you could do this. You put a little cable management, you run them down the sides, you run them back, and you wind up with a bunch of slack to deal with to make it clean and everything else. And so I've got 2 24-port switches here, and we're actually going to be replacing all of this with a 48-port. But you have to think about why you would do this. So there's all of this space right here, above even. Right here is where an average person would stand and do work without too much discomfort. So I understand why the security guy, the security camera guy, might have put his equipment there. That's where I'd put mine, so I don't have to bend over or sit on a chair. All of this is terrible for ergonomics. And I point this out because a lot of these guys that put these in aren't the ones that actually maintain it, who have to be here for maybe hours. I was here for 3 hours tonight just to figure all this out. Not very comfortable. So even this scenario over here, so there's a table here, and I really appreciate that. I rarely get a table and a chair. But all of this equipment overhead is behind it. So when I have to work on this, I've got to lean over the table. Not easy to do. It's a pain in the neck, actually. I would have put this table over on this side. Put it next to the rack, maybe. None of this stuff's getting used. So you have to think about this when you install equipment. And let me show you another example of this. Typical telco providers will install equipment like this, and you look at the fact that it's sideways. Why is that? And there is a reason. The reason is so that you can see the ports. You can see the LEDs, the activity lights on this. Oops, I just dropped a tool here. On this equipment, and you can access the cabling. And it's the same thing over here with this piece of equipment. So like for instance, you could have actually mounted this up high this way where all that cabling was down because you could stand beneath it and look. But you have to take this into consideration when you mount equipment, that someone else in the future, and it may be you, will have to maintain it and have to troubleshoot it and have to look at those activity lights. So some other things we found here. So all of these 66 blocks on the far sides and probably that one right down there, they're abandoned. So all the lines have been cut that go to them. I think this just kind of loops behind it. So I'm going to pull all these out. Some of the other things I've seen. I'm not sure about what I'm going to do about this. I'm probably going to secure it up overhead and make it so that any cables that do pass through here are secured and they pass through without touching the sides. Probably going to get rid of this mushroom spacer. It's under a lot of stress anyways. And then I'll wind up securing these to the tie wrap points. I might move these to the same opening. There's no reason for them to be on their own opening. And then I'll figure out a way to edge guard this. Not quite sure what I'm going to do. These jobs usually involve a few iterations to figure out. But the fact that I'm going to be putting in new patch panels and redoing and redressing a lot of this gives me some latitude to fix some of these other maladies that go on. Something else that clearly no one's taken into consideration is this hinge point. So you've got a lot of these droopy lines, you've got power cables. In fact, I think underneath there is an outlet strip you can't see. And I've got an outlet strip here. So what should have happened is a bit more of cable management with that. Everything should come through one hole. It should be secured and run up this way. And at least there looks like a decent amount of slack already on the patch panel, so I can probably pull it over to this table to do some work on it if I need to. But so what I'm going to do is a lot of these miscellaneous messy power cables are just kind of randomly run. I'm going to run them all to one side and down. Of course, I'm probably going to put an outlet strip right here. And of course, this is all before I'm going to wind up putting a ups in right about here at the bottom. So that'll clean up a lot of this too, but that's something else I'm going to do. I'm probably going to pull everything back out of that line and go into this one because this hole right here has no edge guard, but this one does, and it's wider. There's no reason why this should have been used which couldn't have been used for everything. So I'm going to clean up a lot of this as well. So the next step in this phase is going to be, I'm going to wring out a lot of these lines from the other end, the far end, and see what comes up. So I'll use my low voltage pro for that. So I'll show you that in a little bit, and start to figure out where some of these go. And the main reason for that is, well, and not on these, this is the cameras, but the main reason down here is I've got a lot of lines that don't appear to be active, and I want to know if they are machines that are off or if they're actual ports that aren't being used. And I'll show you why I need to know that in a moment. Two different tools I'm going to use for testing and kind of mapping out the network. This is the, what is that guy? The Fluke IntelliTone Pro. And it comes with, or it usually uses both of these guys. This serves a specific purpose, and then I'm using a low voltage pro, also a specific purpose. So with this guy, I can get some very interesting things right away. Let me see if this will show up in the light. So if I turn this to service, the very first thing I can tell is at the moment it's an open. So that basically means that out of this RJ45 female port, it does not see any type of connection, and it's going to see either an actual voltage on the line for both lines 1 and 2, and those are the two center pairs, and then the pair that is, the center pair, and then the pair that is on either side of it. And so basically how that's going to work is an RJ45 like this, the two center pins are for a phone line are where that's used, and then the pin to either side of that center pin are the second line. So this guy right now sees there's nothing there. So what I'm going to do now is take this cable, which I've plugged into the switch over there, and try to do this one-handed and see what happens. Okay. So if I plug it in, now it sees the network, and it tells me that, symbolically it also shows activity. So if I'm not here, if I'm just somewhere in the building and I want to know what's in a port, this is very important information for me. And I can even put an RJ11 connector in here. They're physically compatible, and it'll tell me if it sees phone lines, or at least if it sees voltage on both of the pairs. So the other interesting thing about this is I can actually send tone to this line. And now a normal standard telco toner won't work on a network cable that's plugged into the network. But the IntelliTone Pro will do that. So now I've gone to tone. I'm going to turn on my toner, and it'll sync up. Now I'm physically close to it, so I'm going to walk away over here. But the blue line, it's this one right there, is the cable that's hooking to it. So just getting in the proximity. Let me see if the light will show it. And as I get right up on it, it gives me that full strength. So that's a real handy tool when dealing with Ethernet and trying to figure things out. So here's another tool that I find very handy. With the IntelliTone Pro, yes, I can. This piece detaches, and I can do cable testing. Let me turn this guy on while I talk. But the most important thing, let me turn this guy off too. Most important thing, the whole reason I got this guy was for the ability to beacon, and that's this little beacon test. So I'm on the RJ45 data portion of it. It's the only one portion I actually need or use for this. But this feature is much more it's much more expensive in any other tester that I've found. And it's simple. So I'm going to plug this guy in, and this would be a scenario where, let's say I'm downstairs, or I'm somewhere on the floor, and I got a cable and I don't know where it goes, and maybe I don't have this or anything, but I can't send standard tone. I want to know where this is. I know it's on the network somewhere, but I don't know where. So I'm going to go down to my options, and I'm going to choose the beacon test, and it only uses 1, 2, 3, and 6, and hit OK. And so it tells me that the beacon feature is active. And so now what I'm just going to do is waltz over here to our switches. So you'll notice that every single switch shows, it lights up. And actually these are kind of handy. I really don't like when lines are blocked over like this. And then these are all separate from that. But it makes it handy in this particular moment when I'm trying to look for stuff. So what I'm looking for is a blinking light, but I'm looking for a slow blinking light. And I think I found it right there. There it goes again. So what is that guy? I can't even see. I'm looking through my camera. So that's 11. And I go over here to 11, and there it is. And that's definitely the cable. So if I can see the activity lights, and I can, and this one also, it's pretty easy to do. But this works everywhere because it's part of the standard. So like even if I go over here and look at this thumb switch, it would work in here with those activity lights. It would work down here with those activity lights. So this is a super handy tool for tracing cables that haven't been labeled, haven't been mapped or anything like that. Absolutely worth the money to get this low voltage pro. I think they're red now. I think the screens are backlit, so you don't need light in the room to use them. So super handy. Love this tool. It's saved me tons of tracing and troubleshooting. Here's a typical example of what I'm running into at this office, and what I actually run into a lot. So here is somebody's workstation, and what's here is another router. And you would normally see this if it was even done correctly without using the WAN port. So by putting whatever this is probably the feed from the network room, by putting it into the 4 LAN ports, it becomes basically a switch. And actually you can configure these to just be a switch. But to do that, you need to not use the WAN port. And not everybody catches that. Especially because the problem with this is typically if you haven't configured this just to be a pass-through a switch, or I think they call it a bridge, this winds up isolating this equipment from the rest of the network. That's just the way that routers work. There's a WAN and a LAN, and they only can see each other through the router. I don't know how this is configured, but we want to eliminate it. Anyway, so the only thing here is this PC and this big printer. So I have a network drop way back there. Also have another network drop right here. So I'm going to have to figure out what's in these lines. So I'm going to wind up popping these off and see if I can find out where they go. I'm hoping that these weren't like torn out or anything like that. So we'll find out real quick here. Quick thing about these wall plates, I'm a real fan of them. I've seen them a lot. I'll probably start stocking on these soon if I find the right version. So what I like is the screw that holds it in is sitting behind this bit of clear plastic, and there's a position where you can you basically pop this off and you can put in a label, and that label's not coming off. I really like these. The one issue I have with any I've run into so far is that these are not keystone connectors. So this is not an industry standard. This is proprietary to this brand. So what it basically means is if I need to replace a connector or put in a new one or a different color or whatever, I have to go through this manufacturer. So I'm trying to find an outlet plate like this, a network drop plate, that I can do this. So it's got a good, nice place to put a label that's not going to get torn off, but uses keystone connectors. So hopefully we'll find one. But anyways, I wanted to just show this. I really like these guys. So here's what I've found out so far. So I used my IntelliTone Pro to inspect the ports on this active network drop, and I definitely found that the blue one was showing network and the yellow was basically cut dead, and I think the two above are RJ11s. So I put the beacon function on and definitely found it in the network room. But you'll see here it's marked, it saes P12, and I did find that on the patch panel in port 12, so that definitely checks out, and I'm hoping the rest of them are exactly like this that are active. But here's the interesting part. So here's an actual view of, and this is probably the same way it's set up, and obviously this one doesn't have anything marked here. So most likely this one hasn't been run through, but look at what I'm finding here. So these are blue Cat5 cables. I can see that the RJ11s on the top, which you'll see are slightly smaller, only use two pairs. So they ran a single cable to give them two separate two-line phone line jacks for this, and still have a home run. But the important thing that I'm showing you here is the clues I'm getting. So these are blue cables, and they're of a certain thickness or a certain style. So I'm going to look for these back in the network room and see what I find. So here we are, P12, as I guess I'm figuring out their scheme here. So let's look at the back. Now, here's my problem. All these cables are white. And this is one of the clues you'll use. The style of the cable tells you a lot about where they go. So this is my clue that tells me essentially something is happening in between here that is changing this. So most likely there was an existing infrastructure, and you can see there was tons of infrastructure in here before that was just cut dead. And so someone must have come back through here and cross-connected these white cables to the blue. And so here's what I'm looking here. So it goes down into the floor, and thankfully, let me move this guy over. There's some really wide holes in the ground. So I looked in here, and let's see if the camera can capture it here. If I look down in there, you should be able to see, there we are, that there is some patch panel down there. Looks like a 24-port patch panel that's basically being used, let's see if I can point it here, it's being used as a cross-connect. Yeah, so it's underneath these cables, so I'm going to have to figure out a way to find this crawl space because it looks like it could be pretty handy. So what I'm hoping is that either these guys, this is basically being used as a cross connect, so I have a bit more latitude. I'd like to pull it out of here if I can, but I'm going to have to see if I can gain access there to do that. Ideally, I would pull these patch panels, these cross connect panels out, and try to bring the original cable all the way up to the top. And the main reason for this is to eliminate problems for people in the future. So down in the warehouse, I found this hatch. It was mainly from looking at where all these cables ran, and they had to come to a point like this. So there's access here, and this is most likely where they've done the patch. Now let me show you what I found up in there. Okay, so just looking in and over a little bit, I see a patch panel, but these cables don't go up. So this must be a different patch panel. But definitely here's a lot of these lines that were cut from the earlier infrastructure. So what's interesting I see here is they used the patch panel mainly to tie in these cables, and they ran regular patch cable instead of solid core cable all the way over here. And then way over there is another patch panel I'm going to show you in a minute, and that's the one that goes up. So this is just a lot of extra work. This should have been an interior line that just ran straight to a point here, or they were spliced in. It should have been spliced in. So looks like I'm going to wind up repairing some of this too. But the idea is we're going to be able to reuse some of these lines now that I know where the access is, and eliminate all those switches on the working floor. See how this looks with my light in it. Okay. Well, after a bit of acrobatics and yoga to get across there, I managed to get kind of fully inside here, and you can tell it's dusty. Anyways, way over there is where the other patch panel is. That's where I came through right there. So those lines run over, and this is it. This is the patch panel that we were looking at from up above. And there's the hole where we were looking through. So this, and here's some other guys that go the other way. So the vast majority of them go this way, and then we got a bunch that go this way. So they used patch cable, long patch cables for the front, and then solid cabling on the back. Damn infuriating is what this is. This should have been done with one-to-one splices. This did not save this guy any time at all. This was a lot of extra work having to punch these all down in two separate locations, way over there, when this should have been one continuous run. And if you're already here, why not do all of them? There's the rest of the lines. They're right there. This would have taken no longer, or very little much longer time. And here's some more splices here. I really pity whoever comes behind this. I'm going to do my best to prevent any problems with this stuff. But what this does give me the opportunity is now I've pretty much solved the mystery of this location. So now I know that this is where the lines run. I know where all of them go. So now I can actually look at those extra patch panel or network drops that were coming up as an open and run them up. So I'll send tone, I'll find where the end is, so either over there or over on that side, and I'll be able to connect them all into the same switch. And that way we'll eliminate all those extra switches and routers that are downstairs. So yeah, this is what you get when you try to save money, and it doesn't save you money. So here's an example of, and I've actually talked about this before, I've done this slightly differently, but this is completely adequate. This would have been a simple splice to do, very secure, easy to identify even where they are. You can wrap these in electrical tape if you want, but leaving them like this is perfectly fine. This is a simple and fast splice. So they're, in this case, using a jack to a connector. This would have worked. This would have worked for every line instead of this elaborate patch panel scheme. And this would have saved them a lot of time. So I'm going to probably wind up doing this on every one of these lines. Here's a little example of what we're trying to eliminate. I'm basically here in this office space, and this is down on the first floor. And look at here, I've got myself a little Belkin router. Might be just a switch, might be a wireless access point, who knows? Running up to this network drop. So we know this is a live network drop, and it's being used to share a network connection. The fact is, though, just a little bit over, I've got another network drop. Got a network drop right here. That one looks like it's labeled, so it might even be usable. And a network drop right here. So in reality, all of these essentially network splitters are unnecessary and add further complication to a network that's about to be taken over for management. So we're going to be eliminating all of this additional complication. So here we are. I'm pretty much down to the last few steps I'm going to do on this first night here. So it's after 10 o'clock. And I've been instructed that everybody's going to leave, or at least if everybody's here, they're not going to need any internet connection. So now I can start kind of unhooking things with reckless abandon. And actually, before I did that, I wanted to show you here, I took out all of these abandoned 66 blocks, and that really cleans things up. Got rid of all the extra screws that were left in here. And I wanted to point something out too. So somebody mounted a backboard in here. I don't know if that was done originally or whatnot. I can see it was at least at one point painted, so that's nice. But this isn't always a blessing. And I'll show you why. So this is what looks to be a little bit larger than 1/4 inch plywood in here. Actually, it doesn't even look like plywood. It looks like a fiberboard, which is a terrible, terrible wood to have to put screws in. It's very soft, so it's easy to drive things in, but it's very soft, so it's easy to pull them out, and it's not very strong. And the other thing, let's look at these screws. So here's one of the screws I pulled out, and it's no wider than one of my fingers, but even no long, but even with that short of a length, let me see if I can show you the issue here. So it is going to hit the back of the metal case, or the metal frame of this chassis pretty quickly. So it leaves you just a little bit of gripping power. Now on these 66 blocks, that'll work out okay, but not everybody brings really short fasteners in their toolkit. So you'll notice this guy's loose, and I know exactly why. This guy is already bottoming out against the metal frame behind here. And I found a lot of fasteners. Whoops! I found a lot of fasteners in here that were in the same boat because they were fairly long. This one kind of went all the way through. You really have to be careful with putting fasteners through these. You don't know what's behind here, so something to keep in your toolkit. I don't have it with me, but some very short but very coarse threads are ideal for this situation. And so these barely do the job. They'll do the job on holding up a 66 block where the mounting base, and you'll see that in the right here. You know, these things are really thick because it's only plastic, so it puts you pretty far away from the frame. But if, for instance, I wanted to hang a device like this guy here, you know, where my head is only going to come out just a little bit, these screws are going to be too long to do that. They won't pull it off. So make sure you carry some very, very short, I'm talking 1/4 inch, 1/2 inch fasteners that with some very coarse threads. They're not easy to find, but when you do buy them by the hundreds. So my last step tonight, and I'm already about halfway through, is separating the cabling, power on one side, data on the other. And I understand, you know, this is the hinge point right here, so I'm going to run my power in and sit right there, and then along here and up. So I have all of the security camera equipment off and unplugged, but I kept the individual lines plugged into their respective units, and I just kind of draped the cables over. So I've got this side, this top half done, but you can already see it's starting to improve the cleanliness of this network. And even here, so you can see, like, this power cable comes through, it goes God knows where, and runs through all of that data cable. So I want to get all of this separated. You see how they're all intertwined. I'm going to get rid of this mess. So I might have gone a bit overboard here, but I did a bit of cable cleanup. So I dressed everything to this side. I kept a few of these bundles independent because they represent different networks until they run down here, but I zip tied everything down. Also, new power cabling. So I ran all the power cables to one side, made a stack of the bricks that I secured in with zip ties. Got a secure line over here. This is the outlet strip that just goes for the camera equipment up above. And then the power strip for everything that is their data network. So if I stand back here, I've made a few other changes. So these switches that were widely spaced down low, I've shifted up. So everything is kind of consolidated at a regular ergonomic height. And all the cables have been separated into data and power. So it makes everything nice and clean. And then on the other side, I did something similar. So by bringing the switches up higher, I'm able to dress to the side the long patch panels that are now in this. So this now gives us the ability to at least start troubleshooting easily. So I can look in here, I can make runs. I didn't leave these, or I left these loose. I didn't make them tight, so I can kind of pull cables in and out from here. But this definitely makes working on this setup much easier for the time being. So this, let's see, it's almost 2 in the morning, but I've got everything back up and running. And from here, we're gonna stew over this a little bit and figure out what we're gonna do about the cabling that I showed you below, where they put in patch cables or patch panels. But I'm happy with how this network looks. It is very easy to see the equipment and the layout of everything. There's not a lot of congestion, so this is a good stopping point. And from there, we're probably going to have the customer decide what they want to do, and because it's going to be a bit pricey, or at least a bit of an extra expense that they weren't anticipating. But for the time being, we've got a much cleaner and now fully understood network. One last thing I wanted to mention on this guy, now that I've got everything buttoned back up, is this vertical track that was put in. I wanted to point that out for an interesting reason. So I'm going to hook this guy again. So there are lines, and I found these also came from that crawl space underneath. These white lines here that run straight up through the cabinet. Some of them go this way, and those are the ones that go to the camera system. But these other ones go to all these punch-down blocks, and that was at one point, and probably is partly now, their phone system. So they, as you remember, they spliced into it with those patch panels down below. But this was really unnecessary. To have run these guys inside this cabinet like this, when there was an exterior track that would have been awesome to do this with, and would have made things much more accessible and gotten rid of a lot of clutter inside this. So I really am not happy they did this. Okay, we're back on the site, day 2, and here we've got our backup power supply. This is a 15 VA trip light. I like these guys, a nice little LCD screen there for information. So we've got the whole system now running on backup power. Ultimately, we're also going to have the CPEs over here, and even the PBX system for however long it lasts. All of this equipment will run off of backup power. And at 15 VA, at least with the calculations I did, all this equipment, even over there, should be able to run continuously for about 4 hours, including 48-port PoE switch. So first step we're going to do today, I want to get these patch panels in. and figure out where they're going to get located, and this will determine our jumper cable length as well, down to the 48-port switch. Two 24-port patch panels, one 48-port switch. So we'll want that in very close proximity. I want to move the video system up high, overhead height, basically somewhere in this area, and I want to ultimately start with patch panels across the top, and I want this at basically eye level. And ergonomically speaking, and I've talked about this before, so we want the equipment that we need to work on, we need to put our hands on and deal with day to day. We want this at this level. We want it at hand level. Nothing to where we have to bend over or deal with. And we'll put the ups down there because it has to sit there because of its weight. So this is what I'm going to make room for, and we'll go from there. Our goal tonight is basically to bring up this new 48-port switch. This is a Ubiquiti PoE switch. I think this is the 500-watt unit. And our patch panels are going to go here. So what I've done, so I can back up here. What I've done is I've moved up the video surveillance network, which is independent, to about as high as I can stand. I could go higher, but I think it would become uncomfortable to service. And so I managed to find slack in all but one cable, so I'm going to check that out when I start running new cables down below this floor. But I'm considering stacking this equipment all on one side just to keep the cabling a bit neater. What we're going to do today is essentially port over everything that goes to these two switches now to this one 48-port Ubiquiti switch. And that will eliminate this hardware tonight. Should be pretty simple. So I wanted to go over also a little snag I ran into here. So here's the second patch panel. This would have gone basically just below that one. And this was the connector I was going to use. I've got hundreds of these. So this is a standard keystone connector that is female at both ends. So it would take the patch cable, go in one side, and then we would basically terminate the other end with a male RJ45. And this was an interesting thing to try, and I may still do it. But what I found, see, there's these little notches in the opening, which is not typical. This is another standard keystone wall plate. So what happens? And even, let's see, let me grab this guy. So at the bottom of this connector are two big bumps, and these would fit in here no trouble at all. They would catch down at the bottom there and work just fine. But these pass-throughs that I got hundreds of, their stop at the bottom is much narrower. So what I found out here is that clip basically just slides right through and won't stay. So I'm not sure what I'm going to do. I might just go get a big bag of the standards for these guys, which is a narrower version of this, because this guy would not fit in here. Obviously, with all these other guys adjacent, would interfere. So they make a version of this that is just as narrow as that. So I may just get a bunch of those and keep these panels. Hopefully, the narrow version of this doesn't have this same problem. I really like this design. It's one stamping of sheet metal. Looks like it was laser cut. I've got my strain reliefs back here, so I'll be able to secure the cable without ever messing with the connection at the connector. Here's a bit more of what I'm thinking of doing strategy-wise, at least at this point. All of these lines to the current patch panel are going to have to get pulled. They're going to get pulled back down underground or under the floor here to the crawl space, and pulled all the way back. So there's a patch panel right here. There's one way that way under the subfloor, and then another one in this direction. So I'm going to pull these all the way back to where they go into the first patch panel and just do a splice and then run a continuous cable back up to the patch panel. That's going to allow me to make sure all the cables come through this hole and not this smaller one without edge guard. Make sure I've got all the proper lengths. So this looks okay. With this current patch panel looks okay. And what I mean by that is, first of all, there is not much of a strain relief. So all the weight of these cables is resting on the insulation displacement joint at the backs of these panels. I like having a bar there. So for instance, there's devices like this that actually screw into the sides of a rack, and they provide a little bit of a base to tie your cables to. There's options like that, but I really prefer this. So I'm hoping to find a way to use these panels or find a different design. I also like these because they're quote-unquote modular, as opposed to these guys here. So if I have a problem with either the insulation displacement connections or anything internally within any port, what essentially happens is that port is just dead. I'd have to mark it off as not available anymore. So basically these patch panels, you can't repair them. So that's one of the reasons I really like these Keystone patch panels. Something else that I'm going to be working out with this is the patch cable distance. Now, I was hoping that I could go 1-to-1 with port numbers, but the switch goes 1, 2, 3, 4, 5, 6 like that. So I'm not going to be able to run these kind of sequentially through. So it's probably it'll be a patch panel here, and then it'll be these two will run to these two, and so on and so on. So that'll at least have them looking even, I guess. So that'll work. So I'm going to be figuring out what patch panel cable lengths are going to run here. So there'll be the second patch panel here and then a space. So I may wind up using a 6-inch and a 12-inch. I may wind up with just two 12s, who knows. I want to minimize, though, unusable space. Now I wanted the space here to separate the two networks. I want a space here because I don't have like 3- and 4-inch patch panel or patch cables. But anything further that we put in, I want to keep everything pretty compact, just to compensate for future growth. So here's where we are at this point, and I'll update you in just a moment. So here we are now with a bit more significant cleanup performed. So I'll start at the top and work my way down. So I moved the router and switch that was here over here, and the main reason for that was cable lengths. So this guy here actually does not have any slack left in it. It is running straight down into the floor. If I find some slack, I'll probably try to give it some relief. But to kind of mitigate those banjo wire issues, I've moved everything over to the cable side, at least with that stuff, and it still looks fine. Let me go back around here. So I've got both patch panels in, and I'll get to those in a minute. And then I moved up the current router, and then the switch that we're trying to eliminate by using the available port on the modem. Here's our existing patch panel and patch cords. I kind of cleaned up a bit of this so that they're all the same type of cable, same length, and it's a 1-to-1 port ratio. So I now have essentially these guys as my straight run offenders. So these are the guys that have a connection somewhere in this facility, but are not going through a patch panel. So these will ultimately become a part of the second patch panel. So I've removed the two existing switches, that this 148 port replaces. And this is an important spot. So what I've done is kind of a mock-up. So I kind of made some guesses here, and I put my two patch panels directly on top of each other, just one, unit of space between that and this. And I left this space because I knew I was going to be using this switch for a shelf for the time being. I'll probably put a regular shelf down here later on. But what I wanted to see was this interface. So here's basically the plan, that I would run one cable from above, one from below, and they would occupy, above and below ports on the switch. Now, what I'm seeing here is that this is a half a foot. So this is a 6-inch patch cable. This is a 12-inch patch cable. And so this one looks just right. This one does not. And the biggest problem with that, let's see if I can capture it in the camera here, is this. So once you get all these patch cables in, this door is not going to close if I use a 12-inch patch cable at this distance. So I have some options. One is to actually create a 1-unit space between the two patch panels, and since I don't have room to go up, I will just relocate these two devices down 1 unit and see what that does. So that's what I'm going to do next. But I wanted to basically show that you go through these iterations, especially when you need the exact right cable length. I ran into this issue with one of my other videos, but it wasn't as severe. But once you get all of these ports filled out, yeah, this is going to be an issue. So there is a bit of mock-up you're going to need to do until you know exactly what cable lengths you're going to need. And in this case, if I wind up keeping this arrangement, the spacing, where there's just one space in between, I might wind up ordering, about 36-inch patch cables, and then maybe 38-inch patch cables to just be long enough to reach there, but not, bow out like they do here. So this is yet part of the experience. So here I've moved these two guys down 1 rack unit, so now there's kind of a even spacing between them all. I'm not completely sold on this idea, but it does happen to solve the issue of touching the cable. And actually I think, it's not going to come through with the light, but I think it still does touch the cable, but it just isn't as severe. What I also did is I moved the top patch panel down to the bottom one, so it kind of evened things out that way as well. So yeah, these are kind of some of the things you're going to run into. Got to mock it up and see how things get laid out. So I think this is what I'm going to do. So I'm going to now need to get some 6 and 12-inch patch cables. I don't have any 8s actually in my box, so I might get some of those as well, just for the future. So I'm probably going to use Monoprice. I like that vendor, and they've got some amazing prices. But the network has definitely been simplified. So just having 2 patch panels and 1 48-port switch, as opposed to 1 patch panel and a bunch of direct lines and just this stack of equipment all spread out. This will be a very condensed, simplified network, and hopefully these 2 guys are going to go away and we'll be left with 1 Ubiquity router. I think it's a USG, so that will live here as well. So what I would do if I were going to work on the security camera system is I'd probably put a patch panel at the very top. I'd put that one there and then start replacing my equipment. Again, probably with a 48-port Ubiquity switch, so that all of these PoE injectors, all of this equipment goes away. 1 unit takes care of it all. So that's probably what I do, and maybe we'll do that in the future sometime. So looking in the back, not terribly exciting, but definitely a lot cleaner. Mainly just from having less stuff here. And I really haven't done a lot of work on cleaning up the cables for power, mainly because a lot of this stuff is still yet to either be removed completely, like the routers here and the switch, or I'm waiting on hardware. So mostly likely what I'm going to do, I'm not going to use outlet strips. Most likely what I prefer to do is run a vertical power strip along the side of the rack, most likely on this side, to keep data on one side and power on the other. Or what's called a PDU, and that's basically a rack mount 1U device that just has a surge protection and a bunch of outlets on the back. And there's a few other options here, so we're going to explore that. But anyways, not bad for a day. Well, an evening anyways. We're getting pretty close, and most likely our next visit I'll have a partner with me, and I'll be underneath here pulling new lines. So we'll be able to replace this this run of cable to this patch panel and then get rid of that patch panel. So we'll run all the new lines up to the new patch panel. So moving right along. It's been a long night, and here is where our network stands. This has been moved down, and I've started to sort things out. So the first 24 ports go to this fellow here. Our feed for the switch is going to be orange, and then any direct lines that will remain will stay over here. And then our new 24-port patch panel is going to start to populate here. Haven't replaced the router yet, or this guy, but that's in the works. This now is a temporary patch panel. I'm still waiting on one from Monoprice, a little bit of a shipping delay. And I'm very happy that I managed to replace all of the security camera equipment and got away with a single 24-port PoE switch. Some of the equipment needed these special PoE injectors, and I have the feeling it was because of a different voltage requirement. But because so many lines were either using the router for this or that, even having multiple small switches, well, every time you make a connection, you lose 2 ports. You lose a port on each machine. So actually, a 24-port switch, even though there was a 16-port, there was an 18-port, and then there were ports being used on the router. Even though those were all being used, 24 ports was plenty, even have a few extra, and they're all running active. So there was also mostly a lot of work done on the subfloor. We've run these 6 new lines and plans for running a lot more pretty soon. Spent a lot of time today ringing out all the equipment in the office, so we'll get to show you some more. But I also wanted to show you just how much equipment has been eliminated from this rack. So here's all the equipment that we've managed to remove. We removed these 2 24-port gigabit switches with the 48-port from Ubiquiti. That's also a PoE switch. So if anything PoE like VoIP phones in the future come into play, these would not have been able to handle it. So a single 48-port replaced these 2 24s. These were switches being used for the security camera system. 4 of these were PoE based, and all of this one were being used. I eliminated all of this equipment. I eliminated the MacGyvered PoE injector, so got rid of that plug. I eliminated the brick that was powering this and several other bricks for this guy. On the shop floor, we've removed 1 router, and several more are coming at probably our next visit. So all of this equipment is now eliminated. There's definitely a novelty factor to making your own patch cables. Finding the right connectors, the right tools, right testing equipment, and hand make your own cables. I remember when I made my first few and I thought, you know what, I'm going to do this from now on. I'm going to always have the perfect lengths, and that's just the way it is. I don't know why haven't other people done this? And I quickly realized that that wasn't really the best choice financially. And this guy here made that same mistake. The fellow that installed this camera system, and actually this is a lot of this is new, but this still remains. was just to tie some lines into a PoE injector, and he thought this would be good. What I'd rather do with this actually is move this over and mount it against the back wall or something and run a regular patch cable and just keep this like that. But that's another story. But these cables take time to make, and you know, I can get 6-inch patch cables. I buy them by, you know, 50s and 100s. They're about 50 cents or less per cable in quantity. So that's not viable. What's your time worth making these? I can do this one connector using a EZRJ, which is a special tool. I can do one of these in about 2 minutes. So, okay, 1, 2, 3, 4, 5, 6, 7, 8 of these times 2 is 16 different connectors times 2. That's 32. So it's a half an hour of your time doing these guys. What's your time worth? One of the nice aspects about using a modular patch panel over a punch-down one is when I'm dealing with these tangled messes. So, like, I've got my, I think this is probably a 25 pair cable that's just kind of woven through all this. This is actually the one conduit that is got edge guard next to the equipment rack. I'm migrating as much as I can off of that one there. I think all that's left on that line now, on that conduit, are analog voice lines that are going to be going away, which is good, because that conduit makes me nervous. Also got, I think, one more line down there to move over to this single large conduit. But when trying to untangle some of these messes, it's nice to have a modular patch panel up above, so I can call to a partner and say, hey, unplug this or that, send it down to me, I'll unsort it and send it back, no problem. Something I'm going to be doing on this project as well, you'll see here that, let's see if I can get a good view here, there really was no thought to structured cabling. So as cabling increased over the years, so did the load on really one support, and this is like that way all the way down. All these lines have just a single plastic clip, and so much more has been added over the years. And you know, while I'm going to be removing this bundle here with the new one right here, this runs diagonally, and I don't want it to do that. I want it to run along the edge and along the edge. So I'm going to have J hangers installed, big 4-inch ones, run them along both of these edges, and that's going to alleviate a lot of these support problems. And a lot less zip ties. They'll just, you know, lay a cable inside the channel, and you're good. Another example of why structured cabling is important. People ran this giant bundle, and they used the conduit for this light fixture as a support. And the clamp that was holding that conduit gave loose, and now it's just kind of resting on this. Luckily, all this is going away. But yeah, you got to give some thought to how you're going to support your cable. You know, looking at one of these patch panels down here in the subfloor, I can kind of see why the previous technician would have done this. I mean, if I was standing here looking at this cable head, you know, and another one on the other opposite corner of this area, thinking about all these individual splices I'm going to need to do and how much of a pain that's going to be, I can easily see going to putting in a patch panel. I think if this had been mounted, you know, further back to add some slack to the line, and these guys are right at the edge, and you can't even add any more. If this had been done, if the patch panel had been put in properly, yeah, I might have left it. And if the cables that came out of it just went straight well, not straight like they do now, but you know, along the wall, along with all the other cables, around the corner, and then completely up and into the patch panel in the rack above the floor. And this would have been leavable. This would have been acceptable. The fact that this patch panel is fairly precarious in how it was mounted and how it's secured and all that, but then it goes to another patch panel before going up to the first floor or to the network room floor, just adds complexity and difficulty in troubleshooting. And so because of that, I'm gonna have to replace it. But yeah, I can easily see thinking about going to a patch panel, looking at all these splices I'd have to do. All right, here we are at a semi-finished state. First thing I wanted to point out is that most of the cables that were run through these other holes have been relocated. In several cases, I found out that the lines were abandoned. This last remaining line is actually an analog voice line I've got to re-splice down below and then rerun. Even for their server, I popped the line up through here and around instead of having it run across the floor. I have to admit, having this extra hole has been very handy. You can see this is the last remaining bundle to be removed from this conduit that doesn't have edge guard down below. Everything else has been either relocated or rerun. This whole bundle here is going to go away real soon. So let me show you where the real work was performed. So I have temporary patch panels in place. These 3 panels. This is the bank of 24, and this will be a bank of 24. You'll see that I, had to space them this way. So this 24 port panel is going to be replaced with these 2 for the time being. These are the new lines. Any new lines are going into this upper panel. So eventually, I'm just waiting for hardware. Both of these are going to get replaced. Here is the security camera system and network. I have finalized the location of these cables. So what I did, you might remember there was some tiny handmade cables that ran to a PoE injector up here. So I did away with that and got just regular longer patch cables. And these are actually now set to length. So that's why you can tell that I turn the knob around on the zip tie when I'm finished and know this is not going to move. So let's take a look at the inside here. Here's the PoE injector that I wall mounted. Wasn't too difficult. And now these lines that used to string across and go in that way are now nicely secured. And then these are now just regular patch cables. So this really cleaned things up in there. I'm very happy with it. So those are all final locations. Everything else pretty much is still in flux. So I got various bundles. So this is waiting to be terminated as well as these, but they're terminated all down below in the subfloor. Some other things, I know my power is not going to move, so I've gone ahead and secured them on all the really important ones. And then I've got my major bundles just zip tied so that they don't fall through. So eventually I'm going to have a large bundle that comes up out of the main hole and makes kind of a figure S before going up into everything. And that's so that when this rack opens, it's not going to cause too much trouble. There'll be some flexibility. So I have a ton of slack below that I'm going to be able to pull from. Oh, I wanted to mention this guy here. So this is just a phone line. These are all the analog lines that run over to the punch-down block over there. You may remember this was on a big mushroom spacer, pretty much same as one of those, and it was just bent over and warped and everything. So I started using these guys, actually, it's one of these. So I got it nice and secure using 2 zip ties on each one. And by basically building up the stiffness with zip ties on these cables, you can pretty much shape them and direct them where you want to go. So, at least for the time being, it's not going to touch any of these sharp edges. And I'm going to dress this out, and eventually I'll come up with a solution for this. But you can do this. You can guide your bundles to avoid whatever you want. So, anyways, wanted to point that out. All right, we're at the critical stage here. I've made a commitment move. I've pulled the primary patch panel. Most all of this office's equipment has been running off of this patch panel, where we've put in a second patch panel for new lines that we're adding. But this was the big deal, so I have to finish this tonight. So this panel is going away. It's going to be replaced by this one, and it looks so nice. I was very surprised that this would work with a 6-inch jumper without a space between, but I'm very happy it is. So we're going to run, as you can see here, one panel above and one panel below the switch. I was thinking of doing them all to one side, but realized that in this case, the activity lights for these ports are on either side anyway, so it really doesn't matter. There's not going to be an ideal location to run the jumpers so that you don't block any of those activity lights. You're going to block them one way or another. So this is the cleanest, most compact way to do this. I'm very much looking forward to doing a before and after with this arrangement. So here we are. We're going to get rid of this panel. We're going to be adding a power switch over here. This is a lighted power panel. We'll label those guys. So we're going to be deciding where that goes in here, most likely somewhere up high. Don't want to necessarily put it too close to the ups, but we'll see. And I'm debating whether to put in another patch panel for the camera system. We'll see. These are already routed to the PoE injector back there. So these definitely aren't moving, but I might patch panel these guys. So we'll see. Anyway, so it's going to be a long night. Have a lot of work to do under the floor here. And I'll probably be showing you some of that real soon. So I did decide to convert the camera system to patch panels. So I'm actually going to reuse this 32-port patch panel for the video system just because I happen to have it. And I don't have any more or enough of the narrow keystone connectors, so I'm going to have to use these wide ones that I got that actually are so wide that they won't fit on a 24 in this arrangement, but they'll absolutely fit on this patch panel. This is a very simple keystone patch panel called I think it's a patch panel blank is the way some of them are referred to. And something that's of note here is that really a keystone connector can mount to just pretty much a rectangle. So what this essentially means is if I need to change the orientation of the connector, I have that latitude with something like this. So I'm using these flat ribbon patch cables. Another one of these instances where I just happen to have these. I don't have enough of these 6-inch patch cables that are nice and round like I prefer. And the reason I really don't like using these is typically you wind up twisting it to line up between the two connections. But with this type of patch panel, actually if they didn't line up, I can always switch the way that the connector goes in, and it would connect and have no problem at all. So I was able to use these patch cables, and this will be a nice, neat thing. Now, something else of note here is this guy is going to sit directly underneath this panel. So I'm not going to have access. I mean, this is a pretty deep switch you can see here. I'm not going to have access to the back of this patch panel, or at least not easy access, once this is in place. In fact, I don't even have easy access now. So I've simply hung the panel, with some zip ties off the rack. After I've already tied it in, I've already moved the cables across, and now I'm putting in my strain relief. So I've zip tied the strain relief just temporarily to the panel, and I'm going to start mounting my guys simply. And I'm going to leave enough slack so that if I ever have to come back to this panel, I can do the same thing. I can just unbolt it, pull it out, and leave it connected to the switch. So if I have to maintain this guy in the future, no problem. I am now beneath the network room, and we're soon to have all of the old cables removed, and now pretty much everything in this conduit is just analog phone lines that I'm really not concerned about. Most likely these are going to go away once we go to a VoIP phone system, so everything will be running off of the network. But the main thing I wanted to point out down here right now is a evolution in cable management. So this was kind of growing organically. So here, for instance, is an example of what was in this building. And over the years, as things expanded, no real thought was given to cable management or structured cabling of any sort. So you wound up with what you see right here. So a lot of cable, a lot of heavy weight, and it is all pulling on one poor little nail, holding on for dear life. And it's like that all over the place in this area. And honestly, it's not an expensive solution to repair, which we're actually about to do. So all of this cabling over here is going to be pulled. All of this diagonal white cabling is going to be pulled, and it's going to follow the wall. But here is what we're going to be putting in. So pretty inexpensive. I think a box of 25 run you about 60 bucks. And a couple of screws and you're good. This is rated for low voltage. So it's got the required radius edges. You can pull cable on it. This one's 4 inches. Obviously, they make them a lot smaller too. But we're going to put a series of these in along here and be able to clean up all of this cable spaghetti. And then right here where they feed down, we're actually going to put in a couple of them facing this direction so that you don't get what you see here, where they start to banjo wire on you. Well, here is an interesting bump in the road on this project, and another good teachable moment. So we had, and during our time repairing and redoing the cabling in this business, one of their phone lines went out. So ran tone, and it did not make it to the PBX system in the network room. I did, however, start to read it as I came in through the subfloor and started waving around. And what I found were these 2 punch-down blocks, these 266 blocks, actually mounted up against this joist, up high, out of sight. And that's what I'm going to talk about. That's why these were a bad idea. No technician troubleshooting this in the future would have even guessed that they would have strung in extra 66 blocks. Now, I understand what was going on here. These were splices. Again, these were cut cables from a previous system that needed to be reused. But a straight splice would have been the smart thing to do and simply run them all the way to the PBX system. But the second thing that I need to tell you guys is this. Build your cabling as if you have to maintain it. Run your cabling as if you have to troubleshoot it. I'm so often seeing a 66 block punch down exactly like this one. Absolutely unmaintainable. They run their lines as straight as possible into this block. No service loop, nothing. And weave it in and out of the base. So this is never coming off to repair. You'll never get this block back off of this frame after this. And for instance, this is a line that went bad. And I can see here, these are the pairs that broke off. Well, good luck getting more slack out of that. Looks like I'm going to be stripping this back, pulling some more out, doing a lot of extra work. When you build these, put in a service loop. When you run these through, make sure that you run them in such a way that you would be able to pull the panel, that's why these have these clips here, pull the 66 block off of the mounting frame. Build your systems as if you are going to be the one to maintain it, to troubleshoot it, to repair it, and to upgrade it. So here's where we stand after another long overnight stay and then some. So all our data cables have now been inline spliced. So all 3 patch panels in the subfloor here have been removed. We're now working on cleaning up the cable runs, and we're going to have cable hangers all throughout this area, and I'll show you that better in another shot here. This was a surprise to find. So now we've got these extra 66 blocks, and so I think that whoever the technician was that put in patch panels for the data cables as an intermediary mass splicing device also used 66 blocks for voice line splicing in the building. And I am going to strongly suggest that we do the same amount of splicing with this. The problem being that these lines are assumed to be to a certain location, but we don't know for certain what happens at this point. And this is simply another location where something can go wrong. So I'm going to suggest that we also eliminate these 66 blocks in the subfloor. As well, the cabling that is left is the last of the cabling that runs diagonally up to the network room. It's the last of the cabling that uses a conduit without edge guards. So it would be in the best interests of the customer to have these lines replaced. And so that's what I'm going to suggest. Here is the beginnings of the structured cabling install. What I've got here are J-hangers, 4-inch J-hangers, and what I'm doing is putting one in upside down here so that it doesn't banjo wire when it gets pulled diagonally. Just make sure that the first one overlaps this so there's no chance of anything pulling out. After that, you can definitely run them at a lower level. So this makes the cabling effort much easier and not a big expense in reality. All right, it has been a grueling couple of days, but our network here is getting more and more ideal, more and more to the point that we'll be happy with it. So this is the big deal. It's taken a long time to get here, a lot of different iterations, a lot of test fitting, a lot of trial and error, and we've finally arrived at what we think will be the best configuration for this network, at least for the time being. And what we're doing is running the Ubiquity switch, 48 port with a 24 port above and below, and a 6-inch patch cable. This is the ideal setup. Compact, simple, easy to maintain. The only downside, as I have mentioned in other situations, is the way that the ports are numbered on the Ubiquity switch is, and this I believe is brand wide, is 1, 2, 3, 4, 5, 6. So there's no ability to just run straight across. By contrast, this Linksys PoE switch does it exactly that way. It runs 1 through 12 and then 13 through 24 down here. Not that it matters on this one. So these guys are going straight to that PoE injector on the back wall. And then I managed to use up some of my flat ribbon cable 6-inch patch cables on this guy. I got away with my particularly wide Keystone connectors because this patch panel, this 32-port patch panel, has a much wider space, so at least I got to use up some of this equipment. The nice thing also is that because this camera system here was directly wired, that being the inside the wall cabling came straight to the switch that was here and the equipment that was here, it still means that it's going to be trivial to convert these to these types of connectors. So let's open this up and take a look at where we stand at this point. So here you can see what the backs of these patch panels look like. It's incredibly simple, and I haven't tied down the strain reliefs on these because these still could potentially get rearranged and moved as we comb these out. And because this is just a RJ45 connection here, it'll be very easy to pull and then untangle. This line up above has been zip tied and most likely will not change. This is the most slack I was able to get out of these lines, and we're kind of stuck with that. So most of these guys, you'll see I've got a really, really long amount of slack, and the plan with these actual data patch panels is to actually run a kind of a loop before it goes down. And that will provide two things. One is when this cabinet hinges open, there'll be a lot of wiggle room and ability to move without stretching any cables. The other thing is if I need to actually pull a patch panel away from the rack and let's say work on a table, work on it on a table or something like that, I will have that length to do it. So we're gonna pull all of this as much as we can, get a nice even, and then a nice even surface loop, and then we'll dress that up. So we're definitely, as I've said in many of my videos, getting near the finish line. One other thing is this PDU. So the channels are numbered, and this is, and you've seen me install these in some other systems as well. So this is a PDU with lighted switches. So it'll give you the ability to label what this equipment is, and then if we need to provide support to the customer that may not be tech savvy, I can easily say something like, well, I need you to cycle the power on the modem. Well, that might be easier to say is go to the rack, look for switch number 1, and turn it off. And then turn it back on again. Do you see light? You know, that kind of a thing. So it makes it much more simple to support. So I'm getting quite pleased with the spacing, the look. I'll mention that I have left a 3U space between these two systems, and the reason for that is this 48-port panel or switch is almost completely full now. I think we've got just a couple of available ports, so there's probably going to be an expansion, and we would do the exact same thing as is done down here. So we know we need at least another 3U of space to stay kind of in this ergonomic ideal area. We're already working to still get this switch removed from the system by giving us another available port on the CPE from our broadband provider, and then we'll be replacing the modem with a USG also from Ubiquiti. So we're getting there, definitely getting everything cleaned up. Now, what really cost us a lot of time today was in cabling. And now you can see we've removed all these spare cables. All the cables run in improper locations. This is all that remains of the conduit here that has no edge guard. And as I mentioned earlier, most likely all this is going to need to be removed as there are 66 blocks in multiple places under the subfloor that should have just been splices. But much cleaner. Here's another good example of installers putting in equipment and cabling that have never had to maintain or repair or troubleshoot that very cabling. So these lines have been run with exactly enough length to terminate. In fact, the twist goes all the way into the 66 block. So good luck even pulling these out. You're going to wind up cutting these and pulling them out with the pliers. You're not going to pull these lines out. And they go exactly straight up and over. They're done. Even a line like this where there's a little bit of a loop, just enough. I can kind of see the line here as I pull it. just a little bit extra. So if I had to, you know, isolate this line and test or whatnot, I'm going to have to cut this, and I'm going to lose some length. I've got a little bit here. But here's an example of what I like to do. So I ran this guy to repair, let me get this out of the way, to repair a line that just was bad. And all I had to do was go from here to this spot here and this guy here. So what I did is I ran down and up. I mean, this is free. This doesn't cost you any more time. This won't make your work ugly or somehow look messy. You can do it cleanly. This is Cat5 cable. I mean, it's easy to shape and everything. So I ran down, up, and over to this guy, down, up, across. You can see where I cut over, made another loop, and then went in. Mind you, the most ideal scenario with these is to never have to do a connection like this, where you have two wires, two pairs meeting on one side. Ideally, you have all of your equipment on one side and you have all the service going to it on another, and you use a bridge clip in between. That's so when you do need to test, when you do need to, you know, separate the circuits and test in each direction, all you're doing is pulling a clip and doing a test. You're never pulling a wire and having to re-crimp it or re-punch it down to do it. So ideally, yeah, this wouldn't even be like this. But I'm limited in what I've got to do here. But these are some of the things I like to do because I might be the one coming back here. Here I am now at the home stretch. So all of my ports have been tested, transferred to the new switch. Had a few issues with a few lines on the new patch panel, or at least the new lines that were run. Got all those worked out. And I'm very happy with where we're at this point. So it is now time for the final cable dressing. And this is the tricky part. So I now have all of the lines in and pretty much where I think they're going to be, especially as they run down and over. Mind you, all the splices at the far end are pretty much the same as this. So it is a RJ45 connector with a junction keystone connection bringing the two together. So if I have any major tangles further down there, I can sort that out pretty quickly underneath the floor. So what I'm going to do now is start to dress back all the cabling. And my limiting factor right now is this bundle right here. I've traced all these lines out. This is the bundle as it runs right here, and these are real tight. So there's a few cables in here that pretty much determine how much slack I have in this rack, because everything needs to follow the shortest cable. And so I'm probably going to see if I can lengthen that cable under the floor with either adding a patch cable in between the junctions, or if the slack is available, I just haven't found it. But nonetheless, what I'm going to wind up doing now is dressing all the lines this way. Then I'm going to have a nice service loop so I can take the panel out and work on it if I need to. The two lines that come this way, I've got some slack in that I can use, so I'll have a decent service loop with that. Then I'm going to establish my service loop here, or not necessarily a service loop as much as a flexibility joint. So it's going to make a loop like this, and the whole point is to allow flexing as this cabinet opens and closes. Once I have my shortest cable lengths established, everything else will follow that same length. So even though I have a ton of slack on this bundle here, it doesn't matter if there's another bundle that's shorter. So that's what I'm going to be doing, and once this is finished, I go to the far end and I dress the other way, because right here at the corner, I've got the cabling going under the floor. It goes over this way and then over there to a splice, and then actually in the opposite direction the same thing. So I'm going to dress back from the splice, and all of my uneven slack I'm going to take up in the corner right there. It's going to be out of the way. It won't interfere with anyone who enters the area, and it'll look real nice. So that's where we're at this point. Okay, so here's actually what I've done. So I've fished a cable through, just a temporary pull cable. Pushed it through, used the nice little access hole here to catch it on the other end and pull it through. And then I've just tied a loop around the bundle I'm worried about. So now I'm going to pull this through, and this will be able to allow me, when I'm down underneath here, identify all the cables I need to worry about finding slack for. All right, so here is the other side of that conduit. Here is that pull string or pull cable I ran through the conduit. So this is my bundle, and I can already see that I definitely have some problems. I mean, it was difficult even getting this thing down, and that's because one of the lines is tangled like this. And now I might be able to comb this away higher up, but I have a feeling I'm not going to be able to with this. So now what I get to do is push this line up, disconnect it, push it down, untangle it, and push it back up. One of the nice advantages of having a keystone patch panel is fixing these tangles is super easy and quick. And now I'm going to basically trace the rest of these guys on down the line that I've already started hanging, and see if I can find some slack somewhere along the way. If not, this is going to be my shortest bundle, and therefore all others will need to be of that length. Okay, so we have sorted out the tangled cable that was afflicting the bundle here. I still have it isolated, and now I've kind of separated it from the group. And now it is a quest for slack. So I'm going to find out, I'm going to trace these lines out and find out which one has the least amount available, and see what I can do to it to maybe give it some more length and go from there, because this is going to ultimately determine just how far I can make all the others overhead. So yeah, this is the fun part. This is when things start to come together. All that planning and careful steps taken start to pay off right about here. So what I found out is out of this bundle I've got, what is it, looks like 3 cables that I was able to get some more slack out of, at least a healthy amount. This would be good, and this was without working really too hard. I found 4 lines that were really tight, and I'm going to take a look at that, but I may not pursue it too much further for a couple of other options. And then I found these 2 guys, which turns out to be the ones, these offenders here, let's see if I can show it to you, that are still running diagonally across the area here. This is the only 2 bad lines. So I might actually wind up extending all of these. Now remember, everything overhead in the rack is a RJ45 connector. It's not punched down. It's just an RJ45 connector, male connector. So if I need length on any of these lines, really all I have to do is get a long jumper and another junction connector and send the length right on down. So considering how many lines I have to deal with here, and especially these 2 that look like they may need to be actually rerouted to get through all these obstacles, the solution here is a pretty simple one. I'm going to just use a good collection of jumper cables and send all of this slack back down, and this will not only give me the length I need, but it'll give me the junction connector is going to be down below the floor, so I'll be able to unhook things to sort out any tangles that I'll run into. So this will be the simplest way to do this. It's another reason why you want to use RJ45s in keystone connectors as opposed to punch downs in patch panels. Gives you so much flexibility later on. As you're working away, developing your structured cabling solution, things evolve. So in this case, I've already decided that my corner here on this side, as well as the corner on the other side, this is going to be where I store my slack. So I'm going to have these long pools of cable down here at this location. And the reason is I'm rarely in this corner, so it's not going to inhibit anyone coming through needing to do work. Now, these bundles here, you see that we're coiled down, these These were pulled back from one of the floors, some of the equipment that was removed, and the cable, this legacy cable was still there, so I took it out. And at the time we thought, just dump it here. But this is the spot where I step over to, get out. So I was constantly hitting these cables, getting them tangled in my feet and my belt and whatnot. So, I can make that decision that, this is not where I'm going to store this cable. I'm going to drag it all over to the corner and keep it here, out of the way. And because I'm using J-hangers, making that kind of a move is going to be trivial. So I'm now at about halfway through cutting over these lines here, these 9 cables that need to get extended. These are all surveillance cameras, by the way, in the network. So I'm basically using just a bunch of these, all matching. I forget what the length is, maybe 30 feet, 20 feet, something like that. Maybe 20 feet, maybe 15. I've got a bunch of these, and these were all actually pulled from here. These were the ones that went down to the patch panel under the ground. So I had these left over. So I'm basically just pulling a line, tying it in with a junction, making sure that the clip is pointing away from the direction it's going to get pulled. So I'm going to do this all 9, and then I'm going to send them down until I have the length that I want. And by making this very basic, very quick change to my cabling, I now have solved all of my slack issues. So I have plenty of slack here, I have plenty of slack in these lines down below. So I'm going to now just dress these cables back however I want to, whatever lengths and distances, proportions, I'm totally set. So yet another reason why these modular keystone patch panels are a good idea. Okay, with all of the jumpers run, not these guys, but all of these 9 jumpers run, so these lines are actually quite a bit longer now. I sorted a bunch of stuff down below in the cabling area that was tangled, and now I'm ready to tie these guys back to the strain relief. And once again, I can pull the patch panel off of the rack, and I put a zip tie on both sides to just kind of hold that strain relief in place. But circuits are still live. Everything's still pretty much running as usual while I'm doing this cabling work. I really like this. So I'm going to get all these secured. I'm going to dress everything to this side, work on my loop for being able to pull this out again, and then work out a loop down here for the hinge points. And that's my cable path. Then both of these patch panels will follow that distance-wise and go into one large bundle. Now that the strain relief has been zip-tied down, cut flush as best I could, so make sure that this isn't going to mess with anybody in the future, which might be me. So now that this is secured, I'm going to start dressing this way because the bundle actually runs down this side of the rack. So now is when I can start dressing the cable pretty much similarly to how a 24-port IDC patch panel is, where everything's kind of laid in order over each other and compact. The difference is it doesn't sit back here on the back of the panel. There's this space where you could get a hand in there or a tool or a probe, anything like that, and you still get a nice compact cabling run like you're about to see. So when I say I need enough slack to be able to pull the panel out, it may not necessarily even mean that I need to pull it all the way over to here, especially on a keystone patch panel. I don't really need to have the panel sitting on a table where I'm punching it down and everything else. But look what I'm able to do here. So I'm still connected to this switch. Maybe I can see it that way. Yep. I'm still connected. My circuits are still live. But I've basically flipped the panel 180 degrees. I've strung it up to hold it in position, so I can stand here and dress these cables back without too much strain on my body. And this is one of the things that I really think is wise to do with the panels you do. So these cables here, these two lines which actually go up and overhead, are pretty much my limit. But it's enough. It's absolutely enough to be able to do this. And that's what I mean. I'm going to definitely leave enough slack above here or around this panel to be able to do this again in the future when I have to for any additional work. So here I have the patch panel dressed back, and I like this. I actually was kind of worked out that I had gaps in the tie downs because of the spacing of this, that it gave me some perfect spots to secure this. It's going to be interesting to see what I do or come up with for the 24 ports, but we'll see. Anyways, the idea here now is I have the panel out, I have it turned up, and I have the cables dressed back. So these go in a up in a different direction, but this is the important one. So right where this is, that it allows me to pull the panel out and actually completely rotate it 180 degrees. This is going to start to tell me where my cable slack needs to be. So once I get this for the top rack, I'll have an idea of distance to leave for loops on the rest of these panels and just work my way down. Okay, I'm going to try to do this one-handed. We'll see how it works. So here is where I think I'm going to need to secure this first bundle. So this is the loop. And this is going to wind up getting what I call, shapes. So right where the bundle leaves the last, zip tie right here, I'm going to start shaping this cable so that there's a relatively sharp turn back, so it's not, pushing out this way like its tendency is going to be. But once this gets established, it'll what I'm about to do will go a lot nicer. But here's the concept here. So I have this patch panel basically just sitting on some screws, but this is pretty much where it's going to be. I want to be able to unscrew this panel while it's connected, rotate it 180 degrees, and work on it. And so that is the length I'm going to need. And this is the length that I'm going to now set for the other two patch panels, because they basically use the same strain relief even if there's more pairs. So yep, this is my next step. So here's the first patch panel all dressed out. You can see the tight runs here, keeps everything nice and compact. This loop can be tucked here or anything like that if new equipment goes in here. And let's see how it works for servicing. So if I wanted to maintain this guy, I just go like so, and voila, I have 180 degree rotational access to this patch panel. So that pleases me. Okay, one patch panel done, and I'm now moving on to the second one. This is the full 24 port. And again, I'm grabbing enough slack here that I can basically unbolt the panel and rotate it 180 degrees to work on it really pretty much just at standing height. So, ergonomically this makes sense. I'm not crouching over or sitting at a table. I can just work right here. But the concept I want to get across here also is this is working equipment. I mounted this patch panel and started connecting things immediately, which is one thing I can do, or another thing I can do with these keystone connectors. I could just plug right in. If things change or move around or get rearranged, I can do that and have on this job several times because these are so modular, so easy to disconnect and reconnect. So I haven't done this dressing of the wires until I was absolutely finished and knew that I wasn't going to make any more major changes. I still could, wouldn't be a big deal. Just cut some zip ties and run new ones. But the workflow process here is to get the customer up and running as soon as possible because I can do all of this later. Here is what I decided to do on the 24 port patch panel was this figure S, and I'll show you why in a moment here. But understand, this doesn't take up any space. I mean, this whole plane is already occupied by that patch panel. So having a lot of stuff in this spot is completely fine. Now, let's look at this. So in this above case, it swings out, works a little bit differently. So this was fine. But this one needs to do this and has to have a bit of flexibility. So I've already unscrewed this. Let's see if I can do this one-handed. So when it comes up, let me try with the other hand. So when it comes up, you want to kind of clear this thing, and then it has to clear this. So I have to watch that corner, and then kind of push it, and then it can fall down. So now I have access to the patch panel. So this is the perfect length of cable. I can zip tie this up, and now I've got a working area. And notice that I did not zip tie around the bend for it to do this particular move, so that it has flexibility in the curves. Okay, I'm going to try to shoot this in the selfie cam because of the cramped location. So what I'm going to point out for you, well, actually a lot's happened in the last few days of work here, mainly with electrical, and wound up having to run a bunch of new circuits here that, as it turns out, were a result of the damage of having cables hanging on to conduit, as you'll probably see a bunch are doing right here. You may remember I got rid of a bunch of the guys that were actually sitting behind me. So this particular conduit right here is one that comes down from above and up here's in this network room. So it comes down, and instead of running across this wall and actually finding studs like I did to secure this, it crossed over to the joist and ran through. And now the problem with that is once it gets to here, it has to go back, and people have already run cables across and over and everything else. So I'm actually going to cut this line. I'm going to mount it to the wall here with a junction box similar to this guy here. I don't know if you can see that. There it is. And be able to keep this separate from the data cable. So wish me luck with that. So we've installed these J hangers and run our slack all the way out. Similarly, along the other side where the majority of the cables go, see if I can block the light here. All the way around we've run J hangers, and got a couple of strays here that I've yet to take care of, but that'll be some of our final things. A lot of structural work was done down here, a lot of electrical. Ran some new circuitry to eliminate some of these crossovers. So there used to be a conduit that crossed here and a lot of cables ran across it, so that's now been wall mounted. This is the what used to be a light bar that ran down here that a lot of the cables were hanging on, so since that light bar isn't even used, this has now been redone. This piping here has been supported from below now instead of from above, which makes it easier for a technician to come in and out of here. A lot of strapping relocated to allow for headroom and that sort of thing. So a lot has been done here. I might have not even mentioned it yet, but this spot over here had this box here. I think it's just the downward register for part of the HVAC system. But this corner was extremely difficult to navigate, so I built a wood frame around it to distribute the weight across the metal studs. Dropped some plywood, couple hours work, but this now saves so much time and effort whenever we need to splice in a new line or work at this cable head over here. And similarly, probably not going to be able to see it from here, let me see if I can block the glare. Similarly at the other side, oh, there's the cable head. We've put plywood down to make accessing that area much simpler. So all in all, this area of the subfloor is now a completely different experience to work on. Here's a small example I wanted to point out here in just dealing with bad workmanship. here is the hatch that is basically where I'm going to be coming in and going out, doing all this work back here. And what you'll notice is it's not fastened to this metal frame. And you'll notice it's all the way around. Now, I've already started repairing this. I want to show you one side of it, way it was originally. So basically, when you put in a doorway in a metal steel stud framed building, you need to reinforce this. And this was not done. So actually, as you climb in here and you grab this, you're going to wind up grabbing some really sharp edges that are pretty darn flimsy. In fact, the only thing holding this door in were the fasteners on the other side going into drywall, and maybe the edge of these boards. I'm not sure. So what I've been doing is filling in the gaps, reinforcing with wood all the way around, and then actually fastening through to make this solid. So when a technician climbs up here and reaches around, he's going to grab something solid that's not going to buckle, it's not going to cut his hands or anything like that. Again, you want to be accommodating to your technicians, and this is not one of them. All right, so we're looking overhead on our cable rack here, and a rack cabinet, and this is the problem area. I've been worried about this spot since the beginning as far as how I'm going to protect the cabling and remove all of these burrs. And what I've pretty much decided is I'm just going to, first of all, I'm going to enlarge this opening. So I'm going to mark this out. I'm going to drill some holes here and here and cut to them and make this a much larger opening. And then I'm going to put on some edge guard I found at the hardware store. So wish me luck. So here's the rough cut that I made around this opening. And yeah, it's not, you know, perfectly straight. It doesn't necessarily have to be with what I'm about to do to it. And so the way I did this, I started with, well, I drew some lines here, and then I used this cutout tool. This is actually an electrician's cutout tool, hole saw. Really sharp blade on this guy, cuts through this stuff like butter. So I used that to make these radiused edges, and then my favorite saber saw. This thing has been so handy in such small areas. So for instance, like right here, I was able to just put it on the edge here and just kind of dip that tip in to make these cuts, and this whole time leaving active circuits running. Actually, most of this is all phone lines, but leaving all this running, and I was able to make this cut. So now I'm going to edge treat this, and won't have to worry about this anymore. Now here's this opening above the rack cabinet here with pretty much all the provisions I wanted to put in. So I've got, again, this edge guard. I've also mounted this angle bracket so that there'll be something to affix these guys to. And I'm going to probably wind up putting something here too, like a piece of wood or something to put some cable ties to, so this stuff will be nice and secure. But yeah, this is pretty much a good solution to a really gnarly problem. Let's take a look at it from underneath here, and you can really see the daylight coming through and how much better that is for the cables. Okay, it's been a few weeks, and I'm back here in the subfloor. Wanted to show you kind of the final comb of these feeds and how much more simple it is now that everything has been sorted out. Remember, there was a patch panel here and all kinds of mess going on here. So yeah, just 2 runs, and here they go over to that corner, and the slack is stored there. Run over the J-hangers, and same thing on the far side, and cleverly use a chair to hide some of that too. But yeah, I'm here actually running a new line. The customer requested an additional network drop, and it was a super trivial thing to do now that this whole under the subfloor area has been cleared out, simplified, made space for the technician to work. And the thought here is, not only is it convenient for me, but as a customer, you want your working environment for your technicians to be comfortable. You want it to be, the word is accommodating. Because if a technician is comfortable here and is accommodated to do the work, he'll do good work. If it is uncomfortable, he will do it as quickly as possible and get the hell out. So make your workspaces accommodating to your technicians. So I am very proud of the result and the transformation of this subfloor area. Ladies and gentlemen, this is the final product. It's been a long road to get here. A lot of sleepless nights, a lot of sacrifice, a lot of frustration, but we're here. We've eliminated a whole slew of network equipment that was here, strewn out all around. Actually, this whole box is full of switches and network devices that we've removed from this site. We've also cleaned up in here, mopped the floor, cleaned the tables, removed all the abandoned cabling, cleaned up a lot of the wiring, labeled our cables, added another board up here to run our cables on. Before I open this, let me just show you. This is a new receptacle. We found out that these guys weren't grounded, so got that repaired. All of the cables that used to run along the floor have been removed. This is all that remains, and like I've mentioned, this bundle right here is analog phone lines for the PBX system that most definitely will be replaced imminently. Okay, are you ready for this, guys? Here we go. Voila! Probably the most important thing you haven't seen yet is I've identified my circuits on the PDU up top. And at the moment, our USC router has not been activated yet. We're not ready to move over to that. So I've got a couple of items that I've identified basically as temp, mainly because these soon will go away and we won't use them. That's why I put them on the far side here. So I'm going to start at the bottom. So we have now an UPS that is controlling all of this equipment. I added a narrow shelf. I believe this is only 8 inches deep, and managed to secure our USG router and this Netgear switch, but all of this is going to go away, even the ASUS router. I added this bar right here to secure the cabling, and I'll show you a little bit more of that when I go to the back. I've labeled the patch panels P and B. I really regret choosing B as my lettering and not realizing that P was being used. I probably would have used maybe A, something that didn't rhyme with P. Oh well. And so yeah, you can see the patch panels, my favorite kind, with plenty of slack. Here we've got the security camera system. And we're hoping to soon be able to switch over to WAN 2 and then eliminate the Netgear switch. Okay, let's open the back because there's a lot of work done in the back I haven't really documented yet. Oh, look at that. Isn't that beautiful? So this is the main thing that I haven't really shown yet. And so I've got 3 patch panels, 3 bundles coming down, and I wanted to create a nice flexible loop that's not secured to anything. So it stops here and doesn't get secured again till the back of this board here that doesn't even move. And that way, when this thing opens and closes, there's a nice flexible curve in the cabling to handle that motion. So everything's been secured now. Power has been secured. Everything that needs to be tied down permanently has been. I mounted the power brick with just a nice strap to keep it secured. I've already mentioned this, but I managed to clean up that abomination of a opening there that was clearly in danger of destroying a bunch of cables. And got this all nice and secured and dressed out. The analog phone line run that I'm not even happy runs through this cabinet. I cleaned that up a little bit, at least got everything together. So this is now a drastically simplified network. There's no mess, there's no tangles. Power on one side, data on the other, data along the hinge point, everything coming through one opening that has edge guard all around. So this really is the conclusion of probably the first time that I have been just unleashed to do what I think ought to be done when it needs to be done right. And yeah, I understand that you're not going to always have this kind of situation. Just unlimited time, carte blanche for what I think needs to be done, plenty of rack space. So I'm making sure I have 3U of space between my equipment so I can flip these patch panels out without interfering. You're not always going to have these advantages. You're not always going to have these scenarios. So this may not always apply to your project, but I will say that I'm imagining that some of this can inspire you, some of this can give you ideas. I hope it does. I've been very pleased to see this through, and I hope you have been too.